The next problem I want to talk about is one of my more favorite problems out of this chapter. It's problem 23 on page 511. Number 23. An analysis of variance of data on the mean GPA scores from a sample of seniors from 10 different high schools in Minneapolis gives the results in table 11.11. Without making any further computations, what do the numbers tell you about the differences between the high schools in this study? So nowadays, I think, with computer records are so easy to look up, they could probably just go to each school and ask them, what's the GPA for your school? In other words, do a full census of samples. Rather than samples, do a full census. But anyway, I like the problem nonetheless. So they started a analysis of variance table at the top of page 511. So let me kind of copy out here. We have the source, and the independent variable is the high school. And so they took samples from each high school, and there were 10 high schools, right? And the degrees of freedom total degrees of freedom is 100. That means there were 101 students sampled. So it's roughly 10 from each high school, but not exactly 10. All right, so we have the residual variable here, and total. So here's the idea. What are they trying to measure here? Is there a difference among the high schools in grade point averages? And probably there very well could be a difference among the high schools, and what would be attributed to? It could be attributed to a lot of variables. It could be the backgrounds of the students, it could be the effectiveness of the teachers, the backing of the parents and their child's education. There could be a number of factors like that which impact it. But the initial study is there a difference between the different high schools and grade point average? If there is a difference, then it might bear further study. You might look at other types of statistical analysis. Get more information to try to figure out why, if it turns out to be a concern. So anyway, this data looks rather contrived, and because the numbers are nice and round. Sum of squares is for the high school was 1,450, and for the residual is 9,000. So these add up to 10,450. Those two must add up together. Degrees of freedom. Well, there were 10 high schools. So they've separated this data into 10 categories, 10 different high schools. 10 minus 1 is 9. So 9 degrees of freedom for the independent variable. And the sample size, although they don't tell us, we know the sample size was 101 because the total degrees of freedom was 100. So that's always one less than the total number of samples. And the residual variable degrees of freedom will be the difference here. These have to add up, so this will be 91. So we're left to calculate everything else out. The mean square, and I always put one of these on my final exam because lost my eraser. Here it is, my eraser. I always put one of these tables on the final exam. Students like to kind of fill them out, and anyway, I don't mind. It's kind of easier stuff to think about here. But the mean square, you still have to know what it means. The mean square is the quotient of the sum of squares divided by degrees of freedom. So if I take this line, 1450 divided by 9. 1450 divided by 9 is 161.1. So 161.1 is the mean square for the independent variable. For the residual variable, I'll take 9,000 divided by 91. And we get 98.9. Okay, so we don't worry about totals from here on out. They don't really mean much. The F ratio will be the quotient of this number divided by that number. So it's the portion of the mean squares. 161.1 divided by 98.9. is 1.63. So that's the Fisher ratio or the F ratio. All right, so that's a pretty low number, I think, and so I'm thinking that the p-value is going to make this insignificant. But we'll look it up, and a little more practice at this. So I'll go to the F ratio table, and my denominator degrees of freedom are 91. So what's the closest number to 91? Well, on page 662 at the bottom, it's 80, and page 664 at the top is 100. 100 is closer to 91 than 80 is, so let's use the 100 denominator degrees of freedom, page 664. Numerator degrees of freedom are 9, so go all the way across that page, 664, and it's that last column, 1.69, 1.97, 2.24, 2.59, and 3.44. And our F ratio happens to be above those. And so 1.63 is above, which means that's above those probabilities. Well, this probability was 0.100, so this is greater than 0.100, the p-value. All right, so what do we conclude? Okay, well, we would reject the null hypothesis. No, I'm sorry, we would fail to reject the null hypothesis because the p-value is large. P is greater than 10%. So we fail to reject the null hypothesis, which means there is no significant relationship between the high school and the grade point averages. You know what I forgot on this table was the proportion. And was that in the book? I really meant to write proportion in. I didn't think about it when I did it. So let me get my place back. Oddly enough, the book didn't put proportion in there. That's probably why I didn't write it. But we normally have a proportion column in here. And the proportion column gives you r squared, which, for the record, r squared would be, what would it be? It would be the sum of squares divided by that sum of squares would be 1,450 divided by 10,450. So r squared was 0.14. If I take the square root of that, it means r is equal to 0.37. So it is a moot point because we failed to reject the null hypothesis that r could be 0. In other words, that there could be no relationship here. And so really we don't need this in this problem because we failed to reject the null hypothesis. Now then, did I answer the questions? And I really have lost my place. Oh, I was top of page 511. Huh. Okay, well, they didn't put ratio proportion in that table either. So, problem 23. Without making any further computations, what do the numbers tell you about the differences between the high schools in this study? Okay, well, if I had read the problem first, they expect us to describe what these numbers tell us. So let's go through that. So the table as presented only had these two columns, and looking at these two columns, I would probably say I expect that there's a pretty good chance with small independent variable sum of squares that we would fail to reject the null hypothesis. That would probably be my guess, but it would be a guess because we had not done the computations at that point. I would also say this tells us, well, there were 10 high schools, but the problem told us that there were 101 students. So I like the data. I don't care for the question in the book. To me, the question is, fill out the rest of the table. Let us know if there is a significant relationship or not, and if there is, how strong is it, and what percent is explained. But anyway, so that's sort of a discussion of this problem. I did go through and do the calculations, and sure enough, there is no significant relationship. In other words, there's not enough information here to conclude that the grade point averages are different among the different high schools in Minneapolis. Right, so that's about all I can think of to say about problem 23.